In this lesson, we're going to be discussing the public, private, and static keywords. Our lesson objectives, as I said before, learn the public keyword, learn the private keyword, and learn the static keywords. All of these keywords you probably have heard and even used in our previous video, but now it's time to put the concept behind the name. So public is literally what it sounds like. Public class, this means that the class can be used by all client programs, meaning that it can just simply be accessed. When we create an instantiation of a class, we do so because it is a public class. We can create that and we can access its methods simply because it's a public class. It can be accessed by other classes. We usually have a driver class, and we also have a blueprint. And that blueprint contains many methods, and it's the framework for our object. And we're able to access the methods, we're able to create an object simply because it's a public class. If it was a private class, we wouldn't be able to access its methods. And public methods, they can be accessed by any client program as well. So this goes hand in hand with public class. Generally speaking, you would want private instance variables, or the variables that you see at the top of a class or the framework of a object, and the methods are public so that you can edit the said instance variables, said data fields. And by editing the public methods, you're able, having the methods public, you're able to actually interact with the object. So generally speaking, you want methods to be public. Now, there are different scenarios where you would need, or it would be appropriate to use a private method, but we'll get into that later in the video. Private is pretty much the opposite of public. Generally, we're going to use this with instance variables. Private instance variables are variables that can only be accessed through public methods. So in our methods video, which we'll get to, and which will be our next video, assuming that I actually make it, these instance variables can only be accessed through a public method. So private instance variables can only be accessed by methods in that class. So if I try to access it from another class, or if I try to access it from a driver class meaning that it has a main method, then it won't work because it's a private instance variable. So if we try to access it through a public method that either prints the instance variable or sends the instance variable to us, then it works because public methods can access public methods within the class, the same class as these private instance variables, can access the instance variables and send it to us. And generally we do that through getter methods. Now, private methods are interesting in that we don't use them in the way that we use public methods. So public methods, as I said before, can be accessed through driver programs. Again, classes that have the main method. But private methods are usually used for helper methods, or it's used as a helper method. So if you don't want to keep so much information or so much algorithms within one method, then we create a private method and that method is invoked. And private methods, again, just like private instance variables, can only be accessed by other methods of the same class. So I can't access a private method from another class that has a main method because it's a private method. Private methods can only be accessed by other methods that are in the same class. And restricting access with the private keyword is known as information hiding. So with accessing instance variables, as you can see, we have a basic class, and I omitted the constructor so that we simply get to the concept. So we're assuming that the constructor sets the value of the instance variable age to 18. And we have a private instance variable here, right? So if I try to access that instance variable, it's going to hit me with an error saying it can't access the private instance variable because, well, it's a private value. It can only be accessed by a method in its own class. It can only be accessed within this class. So say I make public class student demo and I have a main method in there, and then I create a student object, and then I access the age, it's going to hit me with a, it doesn't work because it's restricting access. It's hiding information. But if I create the object with the given arguments in the constructor, and then I access the getAge method, then what it's going to do is the getAge method actually gets it for me, because the getAge method is in the same class as student. This is actually in another class, by the way. I didn't write it down, but I want you to assume that this student stud is equal to new student, right? And we also have our arguments within our method, within our constructor arguments, and then we print out the age that we get. Now, I don't want you to get worried about the syntax. What this method does, is just simply returns the age, right? It sends the age to the main method of another class, and then this print statement prints the age that it's given. So if I access the age, it's going to hit me with a big no-no. But if I access the public method that is in the same class as the private instance variable, then it's going to access the age for me, and then it's going to return the age, or it's going to send the age into this print statement. It's going to send 18, and it's going to print out 18 for me. And that's how we access private instance variables. We access it through getter methods. And I'll tell you the syntax of the getter methods in the next video, but understand this. This is a method that allows us to access an instance variable. Now, static is interesting. A static variable is a value that is shared by all instantiations of a class. And whenever you create multiple objects, the static variable will always be the same, because they all share the same memory location. And the memory allocation only happens once. Now, static is generally used for variables. Now, you can have, and you will encounter times where you'll have static methods. And generally speaking, these static methods and static variables will only be in one location on your computer, no matter how many objects you have. So if you look in our previous example here, if we have multiple students, each student is going to have its own age, right? So if I create 3 students, I'm going to have 3 different ages, or, well, it could be the same value for age, but we're going to have 3 different locations where we store the age. If I have 5 different if I create 5 different student objects, then we're going to have 5 different locations for ages. But static is different in that it only has it for one location, right? So if I have it created within my method, within my class, then it's only going to be there once. It's going to only be there. It's only going to be created once, and all all students or all objects share that variable. They share that method. Now, there's different uses for the static variable, and I'll explain them when I do the demo with the static variable. But it could be utilized for many different functions. One of such can be giving different identification numbers. So with every new student, they get their own identification number based on what time they were registered. So the first student would get an ID of 1, the second student, we know that 2 students are now been registered, so that student's going to get the second identification number, and so on. A static variable can also be used to calculate the total number of instances that we've created of the class. So if we've created 3 different student objects, how does the computer know that we have 3 different objects? Well, we create a static variable, and then whenever a class is created, or whenever a object is created, we increment that value by 1, and all those values, all objects or all instantiations of the class will share that value. And that's what we mainly use them for. Keep track of how many instances of the objects that are there. So we have an example of the static variable in use. So when we create the framework of the object, you're going to be using student in my demo, but I'm also going to be using student here. So just as a rough concept, when we're creating the framework of the class, we generally, if I were using it to track how many students we've created or how many instances of the class we've done, I'm going to set it equal to 0, because when we start off the program, or when we start off the driver program, the class that contains the main method, we're going to have it starting at 0. And then whenever a new student gets created, then we're just going to simply add 1 to the student count. Remember, the increment operator increases the value of student count by 1. So if I create 3 students, every single time it's going to be incrementing this value by 3. And no matter what object that I'm accessing, it's going to return 3 because we have 3 students. So let's go into the compiler and actually show you how these works, because I feel like with all this programming jargon, it's a little bit confusing to grasp, but I feel like if you actually see the demonstration and see how it works firsthand, it will be very, very easy. So let's go on to the compiler. So when we're in the compiler and we're using the public class, we're using the student class that we use in another video, but I've added 2 extra methods. So we already have our private instance variables. We have our constructor that actually creates the object when we, create the object. And we have our get details method that prints out, the first name, the last name, grade, GPA, and class rank, and stuff like that. But I've also added 2 other methods. Now you don't have to worry about you don't have to worry about the syntax of these methods. The syntax meaning how these methods are written. I just want you to know what these methods actually do. So when we access this method, right, what this method does, it takes in 2 different arguments, and then those 2 different arguments set a new name for first name and last name. And then in this method, it has the get name method. This is the get name method. So what it's going to do, if I try to access this get name method, then it's going to return the first name and the last name when it's, executed. So don't worry about how these are written. I'm going to explain them in the methods video, but understand what they do. This one sets the name, this one returns the name, right? So we can get the name, right, the current value of name, and this one allows us to set a new name, okay? And when I kept referring to demo or driver class, right, I meant this. So understand this. This is another class altogether, right? This is another class altogether. This is not the student class anymore. The student class is over here, right? And that is going to serve as the framework of our object. And then this one is considered a demo or driver class because it contains the main method. And when it contains the main method, that means that we will be able to create objects and, alter those objects through our methods. So the first thing I want to do, actually, is I want to make these comments so we don't focus on the other students. What I'm going to do is I'm going to try accessing these private values. So the way that you access instance variables is like this. So we remember how you create a student object. So the student, the class name, right? So you have the class name, and then the identifier. Again, this can be any name. This can be any identifier you want, right? I just put first student. And then we access the constructor by doing equals new. This tells the computer that we're creating a new object. And then this accesses the constructor method. So the constructor method is over here, and it takes in 1, 2, 3, 4, 5 different arguments: first name, last name, grade level, GPA, and rank. And then it sets those as the value of our first name, last name, grade level, GPA, and rank. And we can't do that directly simply because these values are private. But let's try accessing one of these private values. So the way that we access anything from a student object, for any like an instance variable or a method, is by we first get it through the identifier. So this allows the computer to know what we're actually getting it from. So we're getting it from the student object. And what does the student object contain that we want? Let's get the first name. Alrighty, so let's do dot, and then we do first. Is that a capital or a lowercase? Yeah, so it's an uppercase. So name. And remember that now I know that we're used to putting these parentheses here, but remember that this is not a method, right? Methods will generally have the two parentheses, or the opening and closing parentheses, because we're accessing methods. But in this case, I want to see if we can access an instance variable, and instance variables don't have arguments. And in the sense that, in the sense that they don't have two parentheses that we can access. So we don't use the double parentheses, not the double parentheses. We don't use parentheses when we're accessing instance variables. And let's see what happens to the compiler. So we save it. Let me make sure this is at the very least saved. And let me compile and see what happens. So as you can see, it says first name has a private access in student. And what happens is that you can't access the instance variable from another class. This is another class altogether, remember that. And we can't access the first name instance variable because this has been specified to private. And when it says private, when it's a private instance variable, it can only be accessed by methods within its class. It can only be accessed by other things in its class. So if it's not in the student class, then it cannot be accessed unless, well, we have a method that returns it for us. So let's see if we have a method that does it for us. We have a public string get name. Now this returns the entire name. If we don't want to return the entire name, again, I can remove that here, but I'm gonna just put that, just for the sake of doing it, I'm gonna put return the first name and the last name. So this is a public method, not a private method. And public implies what? That it can be accessed by other classes. So let's access it. So we have our first student object, right? And we're accessing its get name method. And unlike instance variables, it's a method. So we have the double parentheses. Sorry about my scrolling. It's a little bit too responsive. So yeah, unlike the unlike the instance variables, it has these two parentheses. It has arguments. So we will be putting the parentheses here. And let's see what happens. Build, compile, and let's run. And it returns the name, right? The name that we set it as within our constructor. And the reason why I can do that, the reason why we're finally accessing the value within this private instance variable is because we're accessing a method within this class, right? So we have the student class, and within the student class we have a public method, and that public method can actually access the instance variable simply because it's within that class, and private instance variables can be accessed by methods within their own class. And within their own class, we have a get name method, and it's a public method. So it can be accessed by other classes, such as this student driver class. Now, say if we had it set to public. If we had it set to public, would we be able to access the name? So we have a first student, and again, we're going to access the instance variable, and instance variable doesn't have parentheses because it doesn't have arguments. So let's run it, compile. And we don't have that error anymore because we changed it from public to private. And when we change it from public to private, then we're able to actually access it from another class. So when you change it to public, that means that it can no longer be accessed just by methods in its own class. It can be accessed by methods in other classes, such as this one, right? Another class, and it's accessing the first name instance variable. No parentheses, again. So let's run it. And it prints out Tony. Again, the method that I had printed out both the first name and last name, but I'm accessing only the first name when we're accessing the instance variable. But I can account for that just as easily. So let me add a space, and let's access the first student dot last name. Let's see what happens. And it hits me with an error because last name is a private instance variable. So to fix that, we do public, and we run it. So build, compile. We no longer have that error, and then it will print out the entire first name and last name. Well, I have it initial to first name and last name. Anyway, that's how we have private. That's how we use private or public instance variables. But generally speaking, you would want these to be private. Generally speaking, you want these to be private. That way nobody's editing it directly. You need to access it through a public method such as this one, right? And when you have it accessed by a public method, then you're able to access these private instance variables. Again, I'll share you how to make getter and setter methods in the next video. Now let's move on to private versus public methods. Right before I start hitting on static, public versus static methods are roughly around the same concept as instance variables. If it's a private method, then it can only be accessed by methods within the same class. It can only be accessed by methods in the same class. But if it's a public method, such as this one, such as this one or this one, then I can access it from the student driver class. So as you can see, I can actually set a new name. So what does the set name method take in? It takes in a first name and it takes in a last name. So what do I do? Well, let me change the name by accessing the student. So we access it through the identifier, and then we do set name. And then let's say that he's not Tony, he was actually Robert. And his last name is still S. Let's just put that there. Alrighty. And we also have a method that returns the name, so we want to see if it actually changes the name. Let me remove this print statement because we're not printing anything. And let me add the print statement where we actually are going to be printing. System.out.println. And it's going to be printing first student.getName. And then we're going to print it right after it changes the name. And then we run it, and it changes it from Tony S to Robert S. So, right, so this print statement executes right before we change the name, and it's going to print out the name that we used in the constructor. And then we change the name, and the reason why we're able to change the name is because we're accessing a public method. So we can access this public method from this class because a public method can be accessed by other classes, such as, well, this one. And we change it from Robert to S. And then when we print it again, we get a new name because we changed the name from Tony S to Robert S. Now, what happens when I make it private? Now let me go into my class, my driver class, and I try to compile it, and it hits me with an error because set name has been set to private access, and we cannot access the private method. Now, generally, you would use private methods when you're creating helper methods. Helper methods are used to just simply lower the amount of work that needs to be done. So if I were to make so as you can see, I made get details private in my free time when I was preparing for this video. So as you can see, if I were to make this public again, right, so it would work, and what it would do, it would run it, right? But if I wanted to print its details, right, I wouldn't be able to access that method. So let me do first student dot get details, and let's run it. And hits me with that private access problem again. But let me show you how we can access this get details method from within the class. So inside this public method, I'm actually going to include a call to get details. Right? So after I change the name, Actually, it would be a much better idea if I didn't put it there. It would be a better idea if I put it in here. Okay, so that's a good idea. If I put it over here, it will make much more sense because we could see the change in the values. So now, instead of accessing get details, what I'm doing is that whenever, let me close these spaces, whenever I access the get name method, it's also going to access the get details method. Oh, must have made a mistake there. It's supposed to be get details. Much better. So this is a public method that is within the student class that is able to access a private method within the same class. So private, again, implies that that it can only be accessed by other methods in the same class. So get details is in the student class, and get name is also in the student class. Therefore, get name can access get details, but get details cannot be accessed by this class. So we have to do it through this public method. So let's see what happens. Can we compile it? Yes, it can compile, and when we run it, the get details method is able to be executed. So what it does, it prints out the values, right? It prints out the name because we told it to print out the name. It returns the name. Remember that. And then it sets a new name. Then it prints out the values. As you can see, Tony S is no longer Tony S. He's now Robert S. And then it prints out the new name. And we never call the get details method from this class. From this class, we never actually call the get details method. And we really can't do that because it's a private method. We can't access it from this class. But guess what? It can. A public method within the same class that we can access, and we are accessing it through the get name method. The get name method is public, and meaning we can access it, and then it can access the get details method that is private, that we set to private. Now, the final thing I want to cover in this video is the keyword static. Now, static is interesting in that it's interesting in that up to this point, what we've been doing is when we create objects, every value or every variable in that object has its own value. So if I create, as you can see here, this basically has created 3 different objects, right? And these 3 different objects create 3 different values for first name, last name, grade level, GPA, and rank. So you could kind of say that, there's 1, 2, 3, 4, 5. There's 5 pieces of information per object. And we have 3 objects. Therefore, we have 15 pieces of objects. So if I do, let me make get details public so that we can actually access it. Public. Okay, save. Let me do first student dot get details. Hopefully I can spell that correctly. Let me do second student dot get details. Let me do third student dot get details. So if we compile, again, we change the access to public, so now we're able to access it. And when we run it, we have 3 different values for first name, last name, grade, GPA, and class rank. And even if their numeric or string value is the same, such as maybe their GPA might be the same or their grade level might be same, right? They're stored in 3 different locations. Right? So we have 15 different locations where we store this object. We have 3 places where we store first name, and that one of them has the first student's name, the second student's first name, and the third student's first name. But what happens if I create a static value, and it's going to be called student count? It's not a method, and we're going to set that equal to 0 for now. Now what happens is that even though we have there's not the, let me run this again and run. Even though we have 3 different locations where we store first name, last name, grade level, GPA, and class rank, meaning that we have 15 different locations, right? We have a first name location for the first student object, a second student first name, and a third student first name, and so on and so forth. And we only have one place where we store this student count across all 3 objects. So I can create as many objects as I want. There's only student objects that I want. To be more specific, there's only going to be one location where they're going to store this value. This value is only going to be created once. This value is only going to be created once. And it's accessed by the same location. It's in the same location for every object. So that means every object is sharing the same static student integer student count. For example, now, like I said in the PowerPoint, we're gonna usually use this for tracking how many instances of class that we make. So whenever we create a student object, let's increase the student count by 1. All right. So let me compile that. And this, whenever we create a student object, it's gonna be always, whenever we create a student object, the student count is gonna increase by 1. So let me close this and let me remove this. Now, like I said before, the student, actually, I forgot one more thing, and we need a way to access these private static integers. I can make it public, but I just want to show you that we need to usually make we generally want to create a getter method for these static values. So public static, it's going to return an integer, and then it's going to be get student count, and it's going to return the student count. Okay, good. Again, don't worry about the syntax, but understand what it does. Returns student count. But you already knew that based on the method name. Let me just copy the method name there. Now the way that let me make sure this compiles correctly. Good. Now the way that we access anything that's static within our class is very different from the way that we would access something public. So when we access something public, we're doing first student, for example, like if I were to, create a first student object, and then I access a public method, such as get details that I made public in this video, this would work simply because, we're accessing a public method that is non-static, meaning that every student that we create gets its own get details method, its own unique get details method. Sorry about that voice crack. But when we're accessing anything that's static within, or static method, or static value within a class, we access it by the name of the class, and the name of the class is student because that's the method declaration we used. And then we access the static method. So the static method was get student count, and boom. Let me keep this comment. Let me make it a comment so that's not interpreted by the compiler, and let me show you how it works. So this is can compile. So you're probably wondering, how is it able to access a method without creating? Well, it's not accessing an object per se. It's accessing a location of this class. This class has already created a location where we store student count, and that student count has already been set to 0. But whenever we add a student, whenever we create a student, what happens to this value is that it's going to increase by 1. So this has already been created. The student count, the static value for student count has already been created. And if we run it, let me, for example, print this value out. System.out.println, and then let me copy this, Command X, Command V, and then close that. Let me compile that, and let me run it. It's going to print out 0. That's the value that we set for student count. Now, what happens when we create an object? build compile, build run, and it prints out 1 because when we create the object, what happens? It accesses this constructor and it increases the value by 1. So let me show you something. Let me put this over here right before we create an object. And let me do it every single time that we create an object. And let me remove the comments so that we can actually execute it. So we're accessing the getStudentCount right before we create an object, and then any time that we create an object. And I want to show you the change of this value every time we create an object. So we run it, compile it to make sure it works, and then we run it. And as you can see, it goes from 0 to 1 to 2 to 3. And the reason why is because, well, when we're accessing the student object for the first time, it doesn't have any students created. Think of it like it's a database. There's nothing in that database, and we've already set the value to 0. The value has already been set to 0. If I were to make this 1, right? Let's say if there was already a student there, right? But we didn't create it within this driver, right? We can have this static value set to 1, right? And then let me save it. So Command S. Let me compile. And let me run this. So as you can see, it starts from 1, 2, 3, and then it goes to 4. That value gets incremented. So every time that we create a new student, the static value for student count gets incremented no matter what. Because all these students share the same memory location for the student count. Student count there's only one memory location where your student count is located, as opposed to, the 3 first names, the 3 last names, the 3 grade levels, and this is subject to change depending on how many student objects you create. So if you create like 20 student objects within your driver, it's going to create 20 first names, 20 last names, 20 grade levels, and so on and so forth. But there's only one place where it's going to have student count. And if we have this set to 0, right, by the time that we create the 20th student object, the student count will be set to 20. And 20 is going to be the value that's shared across all instantiations of the class. Right? All the values of the instantiation of the class are going to share the same student count because it is a static variable. And that wraps up our video on public, private, and static. They're very important words that you've probably come across multiple times throughout this course. And we're going to move on from these, very important keywords into a very important concept that thoroughly needs its own video method. So stay tuned for that video. Thanks you for watching.